I'm Anil Kumar, and in this video we'll understand how a coordinate point is related with trigonometric ratios. The question here is, explain the relationship between the coordinate point P in Cartesian plane and the value of trigonometric ratios associated with the angle formed by the x-axis and a ray drawn from origin to the point P. For simplicity, we'll consider point P in quadrant 1 and then we will discuss the issue. So let us say that this is the ray from origin which passes through the point P, and point P is given to us somewhere here. This is the point P, and the coordinate points for point P are x and y, so that is what it is. Now if point P coordinate points are x and y, it really means that if I draw up a perpendicular here, then y is the height of this right triangle and x is the adjacent side. The angle which we're talking about is angle theta, which is with positive x-axis and the ray going through point P from origin O. Correct. So I hope you understand the situation very clearly now. The statement given here actually describes what exactly we are doing. It says, explain the relationship between the coordinate point P, that is the coordinate point P in the Cartesian plane, right? So this is our y-axis, and the value of trigonometric ratios associated with angle formed by x-axis and a ray drawn from origin to point P. So let that angle be theta. So we'll say let the angle be theta, right? In that case, we need to find how is point P related with sine theta, cosine theta, and tan theta, right? So these are three primary trigonometric ratios. Now, if we consider this particular triangle, we know this is right triangle, where the base is x, height is y, we can find OP. Now, OP is equals to square root of x square plus y square. We call this as R. So let this be R for us. Now, what is sine theta? Sine theta, as you know, is opposite over hypotenuse. So for a point P with coordinate points x and y, it is going to be y over R. Cosine theta is adjacent side over hypotenuse. So adjacent side is x, so it is x over R. And tan theta is opposite over adjacent side, y over x, right? So y over x. So that is how the trigonometric ratios are related with the coordinate points, right? And here we know the value of r is equals to square root of x square plus y square, right? So that is how all these values are related, right? It is kind of important to understand that point P could be in any quadrant, right? So let us discuss that part. So this is quadrant 1, then we have quadrant 2, quadrant 3, and quadrant 4. So what I will do here is, I will actually say this is my quadrants. Let me just draw a few 4 lines here, and these be my quadrants, right? So let me go closer to this. So what I'm trying to say here is kind of like this. So we'll see the sign of our trigonometric ratios in each quadrant, right? Starting from quadrant 1. So we'll write quadrant 1 here. So we'll say Q1. And then we have quadrant 2, quadrant 3, and quadrant 4, right? So in quadrant 1, you see both x and y are positive, right? Since x and y both are positive, r is always positive, right? So here what we know here is that we have positive x, positive y, all are positive. So in quadrant 1, sine theta is going to be positive, cosine theta is going to be positive, tan theta is also going to be positive, right? So that is how these relations are going to be in quadrant 1. In quadrant 2, what do you observe? In quadrant 2, which is this quadrant, x value is negative, right? So x is negative, but y is positive, right? So here x value is negative, y is positive. So y over r, both are positive, and therefore in quadrant 2 is going to be positive. Cosine x is negative, so negative over positive will be negative. Tan y over x, so x is negative and therefore it becomes negative. In quadrant 3, we have both x is negative and y is also negative, correct? So since x and y both are negative, cosine and sine are negative in quadrant 3. But when you divide negative by negative, you get positive. You get the point? In quadrant 4, x is positive but y is negative, going downwards, right? So sine, which is dependent on y, will be negative. Cosine will be positive. Tan will be negative since y is negative and x is positive, right? So the ratios remain same, but the sign changes depending on the position of our point in the Cartesian plane. So I think this video helps you to recapture the concepts which we have learned about trigonometric ratios. That is, for any coordinate point P, x, y, the hypotenuse is square root of x square plus y square, and it is always positive. Sine, cosine and tan theta all are positive in quadrant 1. Sine is positive in quadrant 2. Right? So what I will do here is kind of write down in which quadrant what is positive. In quadrant 1, all are positive. Quadrant 2, sine is positive. Tan is positive in quadrant 3. Cosine is positive in quadrant 4, which we have seen here, correct? And sine is the ratio of y over r. Cosine is the ratio of x coordinate value over r. And tan is the ratio of y coordinate and x coordinate. I think and hope that this video helps you to understand the basics about trigonometric ratios. Let's move forward and now figure out and calculate some trigonometric ratios. Thank you and all the best.